or and we communicate uh, that is communication process, which is in terms of predicting something from the data set. Now, so with respect to sorry, so any data science concepts, uh, the main steps that are involved with respect to this exploratory data analysis is, like, first we'll start with the data requirements. So where, so there can be different sources of data for any organization. Like it is with respect to data requirements, it is important to, like, comprehend or what type of data is required for the organization to be collected or to be stored and all. So as an example, like any application tracking, as an example, we have an application tracking mechanism where it will track the uh, health. It is like just an health monitoring system which will track the sleeping patterns of patients suffering from some any disease like dementia and so on. So in that case, so we require like different types of sensors, and we require some data storage, and even the data is such as we have sleeping data and his heart rate from the patient, and different other terminology, or whether it is technical terms or with respect to health related terms. So how exactly we use that data for data requirements and all. So this just EDA is a single step under which, like, data requirement is one of the just a second. So data requirement is one of the uh, uh, stage. Now once the data is known for some requirement purpose, then we go for data collection. So in order to collect the data, again we have different like several sources, and these data that is collected from several sources must be stored in the correct format, and also it has to be transferred to some right information technology, like uh, who exactly uses this data and all. Now we'll see what are the different formats of data that is collected. Like we have uh, .csv files. Generally the data that we collect from different sources comes in different formats. Like we have html data, uh, csv files, so on. So these data, how exactly we give as a input to some to a model in order to predict on that data. So that is with respect to data collection. Like data can be collected from several objects on several events, like using different types of sensors and storage. Now with respect to the patient data, like I will use sensors in order to collect the data. Now once the data is collected from any source, so we need to, because when you are collecting some data, it is not complete in the sense it is not ready to use. So then we need to apply some data pre-processing techniques. So where the pre-processing involves, like uh, we what we uh, we filter the data, like we use some of the data mining techniques in order to process the data. Like a common task with respect to this data processing is, like, we place the data in some right tables, whether the data is structured or not, or if it is not in a structured format, we structure them, and even we export them in some correct format. Like if the data comes in one format, but that format is not suitable for my model, then we use some other format. So such uh, like exporting techniques will be seen with respect to data pre-processing. So then we'll go with data cleaning. So under this data cleaning, like once pre-processed, whatever the pre-processed data that we uh, perform, it is still not ready for the detailed analysis. So in order to perform some detailed analysis on the entire data, so we cannot stop our process on only pre-processing. Like it must be correctly transformed for the incompleteness, like to check whether there are any duplicates, or whether there are any errors, or whether there are any missing values. So that has to be one of the basic, like significance of data cleaning. So once that, with respect to pre-processing, only just we pre-process data, in order to make the data like in a structured format. So then comes with respect to data cleaning, just will uh, like we'll see whether there is any means data is missing or not, to check whether there are any errors or not. So these kind of techniques are applied on data cleaning process. And these tasks data cleaning in like the tasks such as duplicate checking, error checking, and missed values checking and all. So these all involves such as matching the correct record, finding the inaccurate data sets and all. So that is taken care by data cleaning. And under this data cleaning, other some of the other techniques of data mining, like even we use the data transformation, like we transform the data from one form to other form. So that is also done at data cleaning, like which is generally the data cleaning is dependent on the type of data we use or we study. And in most of the cases, uh, with respect to data scientists or even these data exploratory data analysts or experts, so they generally comprehend with the different types of data sets. So here the with respect to type, the data set is not specific to any single type. So for that, we perform data cleaning. Then comes the EDA process, that is exploratory data analysis. After the data cleaning, so data pre cleaning, where with respect to this exploratory data analysis, so as I already have mentioned, it is just a stage where we actually start to understand the message content in the data. Now, before giving the data set as an input to any model for any decision making or prediction, so or for any analysis purpose, so first we need to know what exactly the data set is. So it should be noted that like several types of data transformation techniques might be required during this process of exploration. Like we have a concept called descriptive statistics. So where exactly we try to describe our data, means with respect to loading the data, or with respect to seeing the different like we have with respect to Python, there is a term called describe sorry, describe function, using which we'll try to describe the entire data set, like the number of columns present in the data set, number of rows present in the data set, so on. uh, like there are other functions, like we have head function, tail function, using which will, for example, in my data set, if the number of instances are more than like 100, some 100 instances, I want to just see only the top 5 instances. So for that we use like head method, which is a predefined function in the Python. Similarly, we have tail method, and in order to describe the complete data set, sorry, we use like describe. So these are some of the descriptive statistics. Like in order to understand some mathematical foundation, we'll see uh, how exactly we use this descriptive statistics. Like we have other terminology, like finding the central tendency. Like in most of the cases, when once after collecting the data means there are some few fields where the data is missing. Now, for example, if the data field is a numerical data, like for example age, now in that case, the missing data will be replaced by applying some of the descriptive statistical techniques, like central tendency. So there is a concept called central tendency, like under which like we'll study three major concepts, like mean, median, and mode. So means the missing value we cannot directly uh, fill with some random values. So instead of filling with the random values, we use some statistical techniques like mean or median or mode, based on the type of data. Like we have again, data is classified based on like whether it is a categorical data, whether it is a ordinal data, so on. So based on the type of data, we'll try to like uh, fill the missing values by using either mean, median, and mode. So when to use mean, when to use median, and when to use mode, and all we'll see. So that is all with respect to this EDA. So the complete process of EDA, that is only with respect to some understand the actual message that is contained in the data set. And once after knowing what exactly the data set, so we just go with some descriptive statistics, like we'll apply some statistical method. Like again, these statistics are of different types, like we have predictive statistics, prescriptive statistics, so on. So under which, like among these different statistical techniques, so we only focus on descriptive statistics, where exactly we use some statistical techniques in order to analyze our data. So that is with respect to exploratory data analysis. Then comes the modeling and algorithm part, like we use any classification technique or clustering technique.
Looks like
Also,
your screen is stuck, sir. Actually, whether it is 17th page only?
yes
Uh,
sir, 17 page.
okay, 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 sir.
So like this is the in detail uh, about exploratory data analysis. Like once after collecting the data, like the exploratory data analysis talks about the structural investigations, like the number of records present in the data set, like number of attributes. Just now I have mentioned, like that is descriptive statistics or descriptive analysis, where it describes the complete structure of the data, like the number of records present in the data, number of attributes. So what type of the data, like data types, whether it is numerical data, whether it is like categorical data and all. So that is all addressed during this structural investigation. Then we have the quality investigation, under which we'll try to find out whether there are any duplicate values, missing values, or unique values. So unwanted values. Sometimes some values may not be useful for our like prediction model, and even this data cleaning or some of the uh, like concepts that we cover with respect to the quality. Like I'm just trying to check the quality of data by using this quality investigation. So finally, like we have content investigation, that is with respect to descriptive statistics. So one of the major statistical concept where we apply like several descriptive statistical concepts in order to analyze the data, like for outlier detection. Even like we use the data mining concepts and data visualization, and even will gather some insights present in the data set. So this complete process of exploratory data analysis, it is only makes our data set ready for like ready to use for our model. So that is all about like exploratory data analysis. If you see this exploratory data analysis part, it is classified into two types. Generally it is like we have graphical and non-graphical, under which we will see like univariate and multivariate. We'll see what is this univariate and multivariate. So the classification of this exploratory data analysis, or that is with respect to graphical and with respect to non-graphical, we'll see in detail. So as an example, just consider this an example where it talks about some professional sports. So I just want to know like how EDA can be used in some professional sports. Now this is a real-time application where how exactly this EDA is used or EDA is applied on that like sports. Now if you see, so with respect to this professional sports, now I want to analyze the player performance. So for that, I'll use this EDA concept. This EDA can be used to analyze the player statistics, like such as scoring, rebounds, so assists, steals, like turnovers, and his strengths and weakness. And even we visualize by using some like heat maps and all, or some short charts, in order to analyze like the player's behavior and all. So whether he is players shooting patterns. So in most of these sports, like we'll see this cricket. With respect to cricket, so we'll see like these analytical techniques plays a major role. like how exactly a player is performing during one season, so how it affects on the other season. So that kind of performance can be done by using this EDA. Even we can, with respect to a specific sport, not only we can perform, we can find the individual like player performance analysis, even we can see the team performance analysis. Like EDA can involve like insights into like team performance by examining like key matrices like the key points scored by the team, their turnovers, their field goal percentage, etc. And even we have some time series analysis, which can help us to identify trends in team performance like throughout the season. As- and even we can perform like analyze the opponent performance, that is opponent analysis. Even with respect to these sports, uh, we use this EDA in order to study the opponent's team historical data. So how exactly they have performed, means the team has performed in history, in past. So based on that, I will go with some strategies and predictions. So even it can even reveal the opponent's strengths and weakness sometimes, like player tendencies and optimal defensive strategies kind of thing. So these are some of the like uh, analysis part generally we perform with respect to a sport. Like even we have the player health and injury prevention. Uh, for that also we apply this EDA like by analyzing the player health data, and even player recruitment and drafting. Even the game strategy optimizations can be done by using EDA. So these are some of the applications with respect to only a single sport. So in a single sport, these are the different domains where exactly I'm working. I'm using this EDA in order to perform some analysis like fan engagement and marketing and all. So these are some of the like EDA application part with respect to a single sports. Now, like we have other like in-game analytics, performance tracking variables. Like generally, many athletes wear devices which track their movements and psychological the data that read from those devices and all can also be used as a input for some predicting models in order to perform, in order to analyze the performance of that individual. Even with respect to any sports, revenue optimization is another thing with respect to ticket sales, merchandise and broadcasting deals, so on. So at every like uh, domain or with respect to a single sport, so these are the different fields where exactly we can apply this exploratory data analysis. So that is how the example with respect to sports uh, uses the concept of EDA in order to analyze. Similarly, with respect to healthcare, like even un- in healthcare, this exploratory data analysis plays a major role. So, the basic one with respect to patient data analysis, like this EDA can be used to analyze the patient medical records, their electronic health records to identify the trends and patterns in the patient health. Even it can use to identify what are the risk factors, like and how a treatment is affected with in the past and so on. So such kind of analysis can be done directly by using this EDA concept. Even we use the disease surveillance, like for monitoring the spread of diseases, like outbreaks, by analyzing data such as the number of cases predicted with respect to any specific disease and all, and what is the geographical distribution of that particular disease. So most of the information can be known by just applying this EDA on any single field of a particular domain, like clinical trials, which can be used to examine some clinical trials data to assess the safety and efficacy of new treatments and all. Even the drug safety analysis. So there we use this EDA again. Like if you see, even for quality of the care assessment, like healthcare facilities can use this ADA in order to assess the quality of care, like uh, by analyzing the patient's outcomes, like readmission. Yes, sir. Like it is something with respect to some medical term, where exactly it is a vigilance under which the like whenever a drugs comes into market, so we'll see like what is the effect of the drug on the individual. So it is like it just say vigilance, it is all about, it talks about some data. So pharmacovigilance is like uh, on the existing, like means there is a kind of vigilance on the drug that comes out into the market. So based on the like how exactly the drug is performed on each individual, so this vigilance data provides that information, and based on the drug's performance it will ensure whether it is safety or not, or how much better it is for a doctor to prescribe a particular drug, you know. Okay. Okay. So that is how, like even in the specific to the healthcare, like there are at every field we try to use this exploratory data analysis. So these two examples, like with respect to sports or even healthcare and so on, even with respect to marketing, like there are several uh, like stages where we use this exploratory data analysis, like customer segmentation. So based on the demographics or behavior or purchase history, I classify the customers. Even for that, I will use EDA, even like product analysis. So with how exactly a product is performing in the market and all. Similarly, the pricing strategies, market basket analysis, you know this, like so for example, if someone buys something, so along with that, what he is buying, like the pattern kind of thing. So we can this thing you have already covered with respect to data mining, where we have the concept called frequency set, under which like we have the best example market basket analysis. Like if someone buys milk, along with milk he will buy like a bread kind of thing. That association or the patterns can be drawn by using this exploratory data analysis. Even the customer churn, that is how exactly a customer is intent towards a specific product and all. So these are some of the different domains that are uh, that uses the EDA. So my main main aim is just to show this exploratory data analysis can be outperformed at every stage of a given field, whether the field can be anything like marketing, sports, or any field you take. So this EDA plays a major role. So in order to like go with uh, the steps performed in EDA, so I already have mentioned this EDA is just a single step taken from the data science. Now again under this EDA, like we have uh, steps like problem definition. Now uh, uh, per- sorry, before trying to perform or to predict something, so we need to define the problem in a clear uh, in a clear view. Like before trying to extract useful insights from the data, it is essential to define the business problem to be solved. So whatever the business problem, that we need to define in an like a clear way. So the problem definition that works as a driving force for the data analysis. That is how the first stage, like the first step of EDA is, which is completely talks about the problem definition. Once the problem is defined clearly, so the solution, arriving to the solution makes the job done easy. So the main task involved with respect to problem definition are like we just define the main objectives of the analysis, or even we can even define the main deliverables, or the main roles and responsibilities with respect to the current status of the data. Even we define a timetable kind of thing, like performing the cost or benefit analysis, so on. So such kind of uh, like objectives need to be defined before like using this data for some before applying this data on some model. So with respect to if the problem definition is clear, so almost most of the job is done. So then comes the so data preparation. Now with respect to data preparation, again I have already mentioned like this step of yes sir. Yes, yes sir. Yeah, I'll give you these EDA stages. Like these are all just some real world examples, sir, only to show where exactly we apply this EDA process. So like then we have the other step is like we have preparation kind of thing. So under this data preparation, like before uh, we perform this analysis concept, like the data preparation concept talks about how to define the sources of data, like how we define the data schemas. Like not only we concentrate on data, even we concentrate on the schema of the data, which talks about the about the data, like even how exactly we understand the main characteristics of the data, cleaning the data. So these are some of the techniques, or like to transform the data from one format to other format, or even we divide the data into some required number of chunks for analysis. As I already have mentioned, the complete data is not used for analysis purpose. In that case, we divide the data into some chunks, only that portion of data that is used as an input for analysis. So that is all with respect to data preparation. So then we have data analysis, like which is the most crucial step that deals with some descriptive statistics. Already have mentioned. So that the descriptive statistics and even the analysis of data, like the main task that are involved with respect to data analysis is like we summarize the data, like finding the hidden correlations. That is whether or whether how the means what is a basic relation between the features or the variables in the data, or even will develop some predictive models for even we evaluate some models. So based on some metrics, even we try to make learn of the model for calculating the accuracies. So some of the major data summarization techniques, like we use summary tables, or even we try to analyze the data by applying some graphical techniques, like we use direct graphs or descriptive statistics like mean, median, mode to explain or to analyze the data. Even we go with some inferential statistics like correlation statistics and searching techniques like grouping, or even some mathematical models in order to analyze the data. Now then comes like we have other term called development and representation of results. Now once the data is ready, uh, so with respect to development and representation of the data, like we present the data to the target audience. So in the form of some graphs, or in the form of some summary tables, or in terms of some diagrams, in order to like generally they are the stakeholders who uses this data set for final analysis. So like most of the graphical analysis techniques, like we have scattering plots, even we have the character plots, histograms. So by using these graphical analysis techniques, we'll try to develop, or we try to represent the results of the data set to the stakeholders. So these are the basic steps, like four basic steps. One is the problem definition and data preparation, data analysis and development. So these the four basic like sub steps under the data science, which are the part of exploratory data analysis. So we'll see some of the terminology with respect to data. like uh, it is crucial to know how exactly the data is again categorized into. We are going to see these different types of data that we encounter during the analysis part. In most of the uh, different as an example, like different disciplines store different kinds of data for different purposes, so that is the one thing. So because of that, when you collect the data, so what are the different types of data available in the data set, you need to know. So as an example, with respect to some medical researches, patient data, or university stores the students and teachers data. For real estate industry, they will store the storehouse data, that is building data sets and all. So with respect to domain, so how exactly a data is stored and what type of data I'm focusing on. So that is a basic idea with respect to any data set. In general, when I say a data set, it is generally like it contains some observations about a particular object. For example, if I talk about a student data or some medical data, that is mostly contains the data about some patients, or the data about the doctors who treat some specific disease and all. So the data set generally contains many observations about a particular object. Like as an instance, like data set about patient in the hospital can contain many observations. Patient can be described by his patient identifier, like ID, patient name, patient address, his weight, his date of birth, his address, like his email, so on. So these are some of the like characteristics we use in order to describe a particular patient. So that here the patient acts like an object. Now under this different characteristics, so what exactly the patient ID is, whether it is means categorized into numerical or categorical, so on and all, can be known by using sorry descriptive statistics and all. So each feature, for example, with respect to any patient data, so each of these features that describe a patient, generally we call it as a variable. So that is what the first thing is. So once the data is collected, so each of the feature, or the characteristic of that particular object, if it is a patient data, like patient ID, patient name, patient address, each one which describes a patient, generally we call it as a variable. Now each observation can again have some specific value. For example, a patient ID, like there is a ID with 123 whose name is so and so, and he will be having his own characteristics or his own features. Similarly, there is another patient with some ID something like 321, so on. So each patient, like each observation can have a specific value for each of these variables. like uh, we'll see the categorization of data. Generally, the categorization of data, the variables are like we have two basic categorization categories or two basic groups. Generally, it is like numerical data and categorical data. Like most of the data sets that we have that we collected from any source comes in two varieties. Either it is uh, numerical data or the categorical data, where the numerical data, like which has the sense of like measurement involved in it. like uh, as an example, the person's age, or the number of students in a class, or the weight, the blood pressure of the patient, so on. So these are all categorized under the numerical data, and this data is often referred to as the quantitative data. So whatever the numerical data we are talking about, it is even referred to as the quantitative data in statistics. With respect to descriptive statistics, so instead of using the data as a numerical data, we use the term quantitative data. So the numerical data set can be again described further into discrete and continuous. So by the word discrete indicates that the data is specified by using some whole number, like example the number of classes in a class, so number of students in a class, so on. whereas continuous, like any measurable value, like any value within some range, like annual income of a family, so on, can be called as the continuous data. So on the other side, like with respect to discrete data, if you see, like generally it is countable kind of thing. So this data that is like countable and its value can be listed out, like the number of students in a class can be listed out. So like the other examples, like we have uh, flip a coin. So if you flip a coin, the number of heads, like in flipping some number of coins, like ranging from 0 to 200 cases. So in that case, like we'll try to list those count in each iteration and all. So any variable, like a variable that represent these discrete data set, generally we refer it as a discrete variable. And the discrete variable generally takes some fixed number. Now, if you see the number of students in a class, it is fixed kind of thing. Like as an example, like uh, if you consider the names of the country, so we have some few like the whatever the countries that are registered, so only those countries can be uh, taken as a value under that country variable. Now, like there is under this discrete, again there is a rank variable, like same like student rank, like 1 2 3 4 so on. So that is comes under this discrete concept. So the other numerical variable, that is like we have continuous data or continuous variable. Generally, any variable that can have the infinite number of numerical values with respect to this continuous data. Like the best example is the temperature. So which varies with respect to the like time, or even with respect to the city where a particular person is living, like the weight variable. Whereas if you consider the weight of an individual, again it is considered as a continuous variable, where the as weight changes. So that is all the continuous variables. Again, we use these numerical data, in terms of discrete or continuous, for descriptive statistics in order to perform the exploratory data analysis and all. Then the other category is like categorical data, where this type of data generally talks about the like uh, it specify the category of an individual. For example, like the gender, the marital status of an individual, the type of address. So these are some of the examples that falls under the category. And this categorical data, sometimes it is also referred as the qualitative data set. Like that is generally we use that word in statistics. Whereas with respect to numerical and categorical, like numerical it is like quantitative, whereas categorical we call it as qualitative with respect to the statistics domain. So now, like in order to understand clearly, like again this categorical data is classified into ordinal and nominal. So where ordinal, the word ordinal talks about it, it is having some order kind of thing, like that can be meaningfully ordered, like grades of a students, the class, so on, uh, is an ordinal data. And nominal data is like it, nominal means like, as an example, the country name, like no intrinsic order of the label. So there is no specific order is maintained with respect to the values that are comes under this nominal variable. And with respect to like quantitative data, like it is already have mentioned, it is also referred to as numerical data. Means the word quantitative generally it is used with respect to statistics, whereas this numerical data, general in the general word we use is numerical data. So that is what like the classification is with respect to discrete and continuous. So all these, like age of a student, height, weight, all comes under like quantitative data, which are numerals. And discrete data, like it will be having some fixed values. Only from that fixed range of values will the variable will take only those specific values. like data that is countable and its value can be listed out. So as an example, the number of players in a team, so the number of employees. So this is an example where like it shows about the employees, means the largest number of like employees at largest companies in the United States. So like with respect to this Walmart, ha- having the maximum number of employees, so on. Now this is like discrete data, or discrete which is countable. Like similarly, we have continuous data that can be shown by using this graph. Like there is a continuous means the values falls in some range, like in some specific range, like with respect to temperature or wind speed, so website traffic and all comes under like continuous data. Like continuous data again, like we have further divided into interval data and ratio data, where the interval data generally does not use the zero as the reference, whereas the ratio data uses the zero as the reference for for measurement and all. And with respect to quantitative, or it is also like termed as categorical data, which is which talks about the qualitative characteristics of an object. Like there is no order we use in order for categorical values and categorical variables, and this categorical data can take even numerical values, but those numbers does not have any mathematical meaning. So that is what it specifies. Even the categorical data is displayed graphically by using some bar charts, pie charts and all. Like some of the qualitative and like categorical, like gender, so even the religion, marital status, so etc. So these are some of the fields which are which takes the categorical data as the input. So then like we have nominal data and ordinal data. Like with respect to under categorical data, like unordered categorical data generally we call it as nominal. If it is ordered by the word, by seeing the word ordinal, it is uses some order, like two possible values like binary, which is like example gender, like whether a person is alive or dead, whether something is true or false. So such kind of binary values are possible with respect to unordered categorical data. Generally we use the word nominal. Like if there are greater than two values, so like no order to be for categorical, like marital status, like religion, so country of birth. So these are some of the nominal uh, where the variable can take more than two values. So similarly, we have ordered like categorical data, which is like ordinal. The word we use for ordinal data is like ordinal, like ratings or preferences. Even the like cancer stage, to know the at what stage a patient is with respect to cancer, the quality of life scales and all. So these are some of the like severity of a software bug, whether it is critical, high, medium, low. So these are all like ordered categorical. Even the experience of a worker, like very great, great, bad. So these are some ordinal data. And just as a like uh, 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 as an example, like I'm just using this problem. Like given the following questions, like I just want to know what are the type of variables of these each uh, question. Like if someone asks like how old are you, like it comes like a quantitative, means I'll specify a fixed value which is like a quantitative. Like where do you live, like give the name of the city, like categorical, because we specify only those cities that are known, means from some list of cities. And how many siblings do you have, like it is again quantitative, but sometimes it is also categorical if we put them into groups. For example, siblings with one, like one sibling, or a person with two siblings, so on. So in such case it is treated as a categorical. But in general, the how many siblings do you have, for this question, uh, means the answer is a quantitative value. And what is your height? Again, it is a quantitative one. Even what is your birth date? It is categorical again. So do you have a pet? Like it is again categorical, whether yes or no kind of thing. What grade level you are in? So again, it is a categorical. These are some of the known questions generally we face in day to day. So how exactly we classify them into quantitative or categorical and all. Like this is another example where I'm directly giving some attributes. I just want to know like what are these attributes are classified into like numerical or categorical. So as an example, like we have age. Age is a numerical one as it can be measured on some continuous scale. Even the gender, it is like a categorical where the gender typically has two or more categories. Student ID, again it is a categorical. Like student ID generally the identifier or label, and it does not have some mathematical meaning, so it is a categorical. Even the test scores, like favorite color, like which is a categorical. Zip code, again it is categorical, which is taken from some the zip code again, some from a limited an- uh, based on the region which a person, an individual live. And the number of siblings, numerical, as just now I mentioned. And the country of birth, again it is categorical. Student email address, again it is categorical. And height in terms of inches, like it is a numerical one. So these are some of the examples, like where exactly we classify the data in terms of like quantitative and qualitative. So example, these are some of the examples. And then like we have some measurement scales. How exactly uh, these measurement scales talks about uh, to describe the data, or uh, we use these measurement scales like in most of our statistical analysis part. Like we have nominal, means the scales are again classified into nominal, ordinal, interval, and ratio. So again these are the part of the qualitative and quantitative. Like the word nominal generally we use for labeling the variables, like without any some quantitative value. Sorry, if someone asks the question like what is your gender, like we have male or female, third gender, so on. So or I will not prefer to answer such answers are categorized under nominal and all. And these nominal scales are they are considered as the qualitative scales, and the measurements that are taken using the qualitative scales are considered as the qualitative data, means that it is considered for some qualitative data. So we'll see with respect to a specific data set, how exactly the data set is again scaled based on whether it is a qualitative or quantitative and all. Similarly, we have ordinal. So by the word already have mentioned ordinal, which uses some order. Generally, these kind of ordinal variables we see with respect to some scale called Likert scale. Nowadays, we observe with respect to most of our day-to-day applications, like real-time applications, like even in banking or something. So once after the bank provides the online service, it will show some Likert scale kind of thing. Like how exactly we like feel about the service, strongly agree, neutral, disagree, or strongly disagree. This kind of scale generally we call it as a scale. Generally we see with respect to most of these online purchases and all. And under this ordinal, it is like named with some ordered variables, which is ordinal. Like how do you feel today, the different answers, like very happy or unhappy or just okay. These kind of questions or values comes under ordinal. And then like we have interval. So I already have mentioned like interval, with respect to this interval scale, like both the order and the exact difference between the values are significant. So that is the reason it comes with the named, and it is ordered, and it is proportionate interval between some variables. Like as an example, the best example already I have mentioned, the statistical uh, like a technique called central tendency, like measure of central tendency, like mean, median, and mode, and other techniques like standard deviation. So generally, we use these like uh, statistical techniques on any interval scales, like finding the Cartesian coordinates, or finding the direction, or degrees from different locations and all. So in such case, we go with the mean, median, and mode on some interval data. And finally, like we have ratio scale. Like again, ratio scale, it contains ordered, and even it contains some exact values, and some absolute zero kind of values will be used for comes under this ratio scale. Like generally, with respect to statistical or mathematical operations, like we have measure of dispersion. So that measure of dispersion talks about how exactly the data is spread over. For example, I have a data set where the data talks about the number of female workers and the number of male workers. I just want to see, means just by seeing the data set we cannot tell the number of male workers and number of female workers. So that is the reason we go for some visualization techniques like bar chart, pie chart, so on. So in order to see how exactly the data points are spread over, so for that we go for the measure of dispersion and all. Even we have the coefficient of variation. So these two terms generally we compute on the ratio scales and all. Same thing. The general classification is like nominal scales. Like we have gender, color, categories are some of the examples of nominal scale. And ordinal, that is with respect comes with respect to rank, ranking first, second, third. Just now I said Likert scales, where we use strongly, disagree. Means the input need not be a crisp value. It generally uses a fuzzy kind of values. That is with respect to ordinal scale. And then interval scale, it uses a range of values. Only within that specified range, the variable will take as an input. Like example, the temperature in Celsius or Fahrenheit, and the calendar dates and all comes under the interval scale. And with respect to ratio scale, just now I have mentioned that with ordinal categories, the feature, it satisfies all the features, ordered categories and equal intervals, and it is true 0 point. Example, like height, weight, time on which we can directly perform some statistical uh, measures. Directly I can apply mean on the weight, or something some statistical measure of dispersion and all can easily known with respect to this ratio scale and all. So these are again some of the measurement scale for that. So to identify the measurement scale, if someone asks what is the favorite color, so the solution is like we have different colors like red, blue, green, which are again picked. We need to pick from some categorical, represent some categories without any inherent order. So which indicates a nominal scale. Like if someone asks which country are you from, then the responses are USA, India, France, Japan, so on, and again without any specific order. So hence it is like again a nominal scale. Rate your satisfaction with our service on a scale from 1 to 5. Just now we have seen a scale, for 1 very dissatisfied, for 5 very satisfied. It is like ordinal scale. In the rank, following in the order of preference, any in action, comedy, or drama. Like for action, for comedy I'm giving 1, For action, I'm giving 2. For drama, I'm giving 3. Now again, it is like an ordinal kind of thing, where ordinal with some categories without any quantifiable. Like I cannot quantify. Like directly, I'm specifying the comedy first, second action, and third. So hence, it is ordinal. And what is the temperature today? Like 20 degrees or 25 degrees. Again, it is indicating some interval scale, uh, because again the temperature is ranging from some specific range, like on a scale of 1 to 10, what how happy are you today? So these are some of the examples that are like taken from some day-to-day life, how exactly these measurement skills plays a major role. Then like next we have the concept of this explanatory data analysis. We'll compare with some classical and Bayesian analysis. So before that, we'll see what exactly Bayesian analysis. So for that, like what I'll do, I'll stop here. So in the next class, like I'll start with this Bayesian analysis, like the classical analysis. Like we know most of the because already this data mining and machine learning. So the basic idea of this classical data analysis is known to you, like data collection or model developing and all comes under this classical data analysis part. So how exactly we what are the different comparisons with respect to classical and Bayesian with the EDA. We'll see in the next class. I'll stop here.
Okay, sir. Thank you.
I'll share these PPT here. And if you want the textbooks, like directly the textbooks are available, a PDF format. You can refer these textbooks.
Okay, sir.
Like how about your attendance? Like they are
I have
maintained.
taken already, sir. I will post it in the group.
Okay, okay, sir. Thank you. Okay then.
Okay, sir. Thank you.
Thank you, sir.